Okay, now we are going to continue talking about body defenses, pathogens, and how your immune system defends you against diseases. Now, let's talk about some things that if we um, if we organize them, if we construct them very well, they actually will prevent a spreading of pathogens. One of the most important things that we should manage and construct very well in order to prevent pathogens are landfill sites. As you notice here, landfill sites are places on land where we put our garbage, rubbish, and other waste materials. We accumulate them, put them at a specific area. Now, of course, landfill sites contain biodegradable, when we say biodegradable waste, that can be decomposed by microorganisms, by bacteria, such as the remains of foods, or anything that can be decomposed, made of organic materials. Now, the decomposition of these materials by bacteria produces gases. These gases are very harmful to the environment, such as carbon dioxide, and mainly the most common gas that is produced by this decomposition is methane. As we know, carbon dioxide and methane both are greenhouse gases. When we say greenhouse gases, that they collect heat, they increase the average temperature in the world. That means that they increase the global warming. They collect more and more heat. At the same time, methane is very flammable gas. Is very flammable gas. That's why it should be controlled. That's why landfill sites should be well constructed. Here we have an image for the modern landfill site. This is modern landfill site. Garbage and wastes are piled up, as you see. Do you see waste area here? Here are the wastes actually are piled up and compressed into even layers in order to reduce space, and we cover them with vegetation. When we say vegetation, vegetation means like grass, trees with soil. We cover them in order to prevent methane gas going out randomly. At the same time, we can use the benefit of organic material that is found in waste. As we know that composite and manure are organic compounds that come from living things, and they are used as fertilizers to enrich the soil and to enhance vegetation growth. That's why we can use the waste products that are found here in order to make trees, grass to grow. Okay, at the same time here, as you see this system, this liner system is found in order to prevent the toxic materials from going down to the groundwater. So we prevent going out of methane randomly to the environment by covering it by many systems, and we can use vegetation in order to cover it. At the same time, we can use the benefit of waste product to the growth of this vegetation. And we have another system which covers the materials from going down to the groundwater, so we prevent the pollution of groundwater, because landfill sites, if they are not well constructed in this way, they're gonna pollute the environment the atmosphere, the air, by many gases, and they're gonna pollute the soil and the groundwater down. That's why we have this system in order to prevent pollution by the garbage or waste products of the landfill sites. Here, as you see, we have gas collection. Gas collection or pipes in order to make sure that methane, when it goes and collected safely. It doesn't go randomly or at high amount or at high rate. It doesn't escape or leak at high rate out of the landfill site in order not to affect the environment, because it is one of the reasons, because it is a gas, a greenhouse gas, and it is highly flammable. That's why it could be collected safely. And some landfill sites can use this gas as a fuel. They can collect it in special tanks and they can use it for fuel. This actually the landfill site, the modern landfill site, you should know it, how it is constructed. You should read all these notes and look at the structure. Okay, now let's go to the immune system. By the way, sewage treatment and landfill sites are shown on page 132, 133. Landfill sites, as I describe it, sewage treatment, you're gonna have it, inshallah, in grade 10. So, no need to know it twice. The immune system, page 133. As we talk in the circulatory system, we talked about lymphocytes and phagocytes. We said that lymphocytes produce antibodies, and these are antibodies that they look like Y shaped. They fit exactly, they are complementary to the shape of the antigen. Antigen is the microbe or the pathogen. The pathogen is the microbe or the invader that invades our body and attacks our body. Also, it is called an antigen. So, an antibody is made against the antigen to fit to it. Do you see how antigens, they have like proteins? These proteins are recognized by our immune system, by lymphocytes. Once they are recognized, lymphocytes produce a specific complementary antibody against. And these antibodies clump to the antigen, preventing antigen from reproducing anymore. So they restrict the movement of the antigen, eventually killing it. Now, so what you should have about lymphocyte, their shape, you have to identify them either from drawings or under photomicrograph. They have one main large nucleus, as you see, and they produce antibodies. The antibodies, they look like Y shape. They are fit and they are complementary to the antigen. Once lymphocytes recognize an antigen, they enhance the work of phagocytes. They give alert or signal to phagocyte to come and to attack this pathogen, because now pathogen is being recognized as non-self cell, is being recognized as an invader. It should be attacked. Okay, so now lymphocytes, once they recognize an antigen, they also enhance the work of phagocyte. They call the phagocyte to come and engulf this pathogen. So here is a phagocyte, as we see. As we talk that phagocyte, they contain digestive enzymes. They have lobed nucleus. They take the pathogen, they engulf it inside their cell by endocytosis. They release digestive enzymes to break it down. Then now the pathogen is broken down and digested, it is completely soluble. It diffuses to the cytoplasm of the phagocyte. Now, these steps, you have to know them very well. Already we described them before. So, phagocytes now come to the pathogen or to the antigen and engulf it. If phagocyte cannot be able to destroy it, now lymphocyte can reproduce more and more. At the beginning, lymphocytes, they do not multiply or reproduce that much, because the reproduction of lymphocytes means producing lots of antibodies, and lots of antibodies needs lots of energy, which exhausts the body and make you very ill and sick. That's why if phagocyte can be able to engulf it, it's okay. If the phagocyte cannot engulf it and the pathogen is reproducing and multiplying very fast, then lymphocyte now should multiply also very fast with phagocyte. Here how lymphocyte respond to antigen. Once they recognize it, here is the antigen, they produce Y shape. Now they should expand. They should multiply very fast and producing lots of antibodies. By the way, here are the mother cells and here are the daughter cells, because they divide. Every cell, as you see here to my cursor, every cell produces two. Look here, this produces two, and this produces another two. Now this produces another two. So everyone produces two. Okay? They divide by mitosis. Everyone produces two. They make clones of themselves. Clones, they make exactly the same in order to produce the same exact antibody. So they make copies of themselves. So expanding here means multiplying of lymphocyte. So lymphocyte, once they recognize antigen, they produce antibody. If the antibody doesn't work, they multiply after phagocyte. Okay, phagocyte, they now are signaled by lymphocyte to engulf. If the engulfment is not working or the reproduction of the pathogen is very much faster than the reproduction and multiplication of phagocyte, that means now lymphocytes should multiply more and more with phagocyte. What you should know, what each one does. This produces antibodies and this engulfs. And you should know that lymphocytes reproduce like this, just making copies. This is what you should know. Okay, now, that's why the first time the one or the person gets the infection, he suffers very much. And he may get so ill and he may show a high fever and it may be very severe. But the next time he gets the same pathogen, then the lymphocytes already they had made the same antibodies before. So when this pathogen comes and attacks the body again, already antibodies are made. They don't take that much time to be produced. Already now they are produced. So look at this. Here is the first time at the infection. Here where we have expansion. Expansion means multiplying or reproduction of lymphocytes, making lots of clones or copies of lymphocytes. So do you see the antibodies? Here are the antibodies. Do you see the projections that are going out of the lymphocytes? Now, the first time, here are the lymphocytes. They are attacking. Some, if lymphocytes stay in the body, they are circulated now. Some of them stay in the body, within the blood flow. Some cells, by the way, they may last for 20 years. Now, the cells that stay after the infection, when the antigen now when the antigen now is killed or attacked and the person is cured and no any symptoms are being shown by the patient or by the host. Now, the cells that last after the infection and they do not go, we call them memory cells. We call them memory cells. They are called memory cells because now they are as a memory for the cells that actually were produced at the time of the infection. So look at the graph. Here are the graph, the same ones that are shown on your page 134. The first graph, which is on the left, it shows the antibody concentration or the production of antibody when the first infection, the first time of infection. So here, look at the time needed to produce the largest or the peak, the greatest amount of antibodies. Look at the second one. Here already we have memory cells. So it doesn't take that much time. And look, the amount of antibodies that are produced. They are many times greater than the first infection because already here we have memory cell. So look at the peak here. It's much greater than the first one. In the second infection, already we can have lots of antibodies. So this is what you should know about the memory cells. Sorry, this is what you should know about memory cells. And these graphs represent at the first infection, the initial, when we say initial, the first. Here is the second exposure or infection by antigen or by pathogen. Look at how the number of antibodies are much greater than the first one because already we have memory cells, so they don't need it doesn't take that much time for lymphocytes to make new antibodies. Already antibodies actually have been made and they are circulated by the body. So now it doesn't take that much time to remake them again, just to clone them much faster and producing much more than before. Thank you.